All right, in this lecture, I'm going to talk about full structural equation modeling. And I want to emphasize that right now, with full structural equation modeling, we're really just adding together all the things we've learned before about path analysis and confirmatory factor analysis. So when analyzing a full structural equation model, we're going to take two steps. We're going to start with the measurement model and make sure that has at least good or adequate fit. And then we're going to fit the structural part of the model. So this approach is really useful because if we ran the whole model, measurement and structural at the same time, we might get poor fit, but we wouldn't really know where to start with respecification. With starting with the measurement component, we can make sure that that's all clean and pretty. And then if we get poor fit, once we add the structural components, then we kind of know that the poor fit is a result of the structural components and not the measurement components. So everything we've learned about identification, model fit, and interpreting parameters is exactly the same. And for identification, we're going to follow the two-step rule, which is basically making sure that the measurement part is identified and then making sure that the structural part is identified. All right, so here's a visual example of the measurement versus the structural model. So in this model over here, we have 4 latent variables: constructive thinking, dysfunctional thinking over here, subjective well-being, and job satisfaction. So in the measurement model, we're focused on the latent variables and what each indicators are. These curved arrows, if you remember, are covariances. So they're saying that we're allowing all these variables to correlate with each other, but we don't have any particular ideas about what directions or what causes what. So in a measurement model, this is what we're going to do. We're going to specify our latent variables, but we're not going to specify any relationships between them besides just letting them correlate together. If we were doing a two-step SEM, we would make sure that this model was identified and that it fit really well. So it's just like doing a CFA. All right, so after the measurement model fits well, we add in the direct effects. So here in this diagram, you can see they've taken off all the indicators and just left the latent variables. And now you see the arrows that go between all of these different latent variables. So here we're specifying that job satisfaction is a result of these other factors over here. So the only thing we're going to change when we're specifying this model compared to this model is that instead of these curved arrows, we're specifying straight lines, direct effects, instead of covariances. So we would run this model and evaluate the fit, and we can still respecify things either within these direct effects or in the measurement model if we really wanted to, but it's really most of our changes are going to be focused on these direct effects that we added in. So the steps here are going to be exactly the same as what we've been doing, except we're going through twice. We're going to go through with the measurement model, and then we're going to repeat everything with the structural model. All right, so for example, we're using the meme again. So our research question now is, how are ethnic identity, exploration, and commitment, exploration here, commitment up here, associated with interest in school? So as you might remember, exploration and commitment are aspects of your ethnic identity. How much have you explored what it means to be a member of your ethnic group, and commitment is how much have you committed to a sense of you know what it means to be in your ethnic group. Research suggests that students who have higher commitment and higher exploration are more interested in school. Just in general, more positive ethnic identity is better. So that's what we're going with theoretically. So our first step is to specify the measurement model. When we specify the measurement model, we're focusing on those latent variables and their indicators. Again, we allow all the latent variables to correlate without saying any particular paths between them. Now, one thing to remember is that I've shown you the arrows here, but in most programs, these are going to be automatically included because they are all exogenous within this measurement model. So as we've seen with the meme already, it's a two-factor model. Commitment and exploration each have 3 indicators. So that's how we would specify that. And then for interest also has 3 indicators. And then the data, they're called motivation 1, motivation 2, and motivation 3. So to set this up, we just say 3 latent variables, 3 indicators each. So now we have to make sure this model is identified. So remember, to be identified, a model has to have 0 or more degrees of freedom, and every latent variable needs to have a scale. So to get to our number of data points, we have to start with the number of observed variables. And remember, observed variables are just our squares or our rectangles here, right? So there are 9 observed variables. And if we use our formula, the number of data points is going to be 45. So now we need to count all these other effects here. So we're going to count our direct effects. And remember here, our direct effects are what's going from our factors to our indicators. Now, before we count this, remember that for our latent variable scaling, if we're using the reference variable method, then we are fixing one of our direct effects to 1. So we're only going to count 2 direct effects on each one. So this one's fixed, 1, 2. This one's fixed, 3, 4. This one's fixed, 4, 5. Or wait, 5, 6. So we end up with 6 direct effects for our latent variables. Next, we're going to count our variances of our exogenous variables. Each of our latent variables is exogenous, so that's 1, 2, and 3. We're going to count the variances of our error terms, so that's every endogenous variable. Each of our indicators is an endogenous variable, so that's 9. And then we count our covariances. And because here, all of these are exogenous, they are going to have covariances included. So that's 3 covariances. That gives us 21 free parameters. 45 minus 21 is 24 degrees of freedom. So our model is over-identified, which is a good thing. Our latent variables are scaled. We are good to go. So our data is collected. We can estimate the model. In this model, these are fit indices, and you can see this is a pretty good fit. We had a relatively low chi-square, RMSEA 0.036 is great, CFI 0.99, fantastic, SRMR 0.026 is really amazing. So this is a great fitting model. All right, so now we can look at our parameter estimates. So you're going to do a similar thing that you're doing in CFA, in that you want to look at those loadings and make sure all the indicators are loading adequately on their factors. And the other thing you want to do is kind of look at the correlations between your variables, and that's going to provide you some initial support for your hypothesis. Now, remember, if you look at the unstandardized parameter estimates, then each of these first indicators is going to be fixed to 1. So that's not all that interesting. What we really want to look at is the standardized estimates. So that's where we're going to see, okay, are these all above 0.40? Okay, good, good. And then we kind of want to see, is there a correlation between commitment and exploration? And we already know that there is, right? So because of our CFA, so that is there at 0.73. But now, in terms of our hypothesis about commitment and exploration positively predicting interest, this is where we can look at these correlations. So what we see here is a 0.31 correlation between commitment and interest, and a 0.37 correlation between exploration and interest. So that's a good sign to start out with, to say, okay, our hypothesis might be supported when we go on to the next step. But this doesn't actually answer the question of whether commitment and exploration predict interest. To do that, we have to specify our structural model. Now, notice this looks very similar. All we're changing is that instead of these being curved areals, just curved covariances, we are now specifying that we think commitment predicts interest, and we think exploration predicts interest. So we're changing these to straight lines to direct effects. And then we can go on to model identification. The fun thing with model identification in this example is that the numbers end up being the same. Okay, so number of data points, that doesn't change. We have all the same variables. The count is going to be slightly different, but we end up with the same numbers. Because now, when we count our direct effects, we have these 6 on the indicators, but then now we have 2 more direct effects. So that gives us 8 direct effects. We should have 2 exogenous variables here. And now we have 10 endogenous variables. So this is incorrect. So we have two exogenous variables, commitment and expiration, 10 endogenous variables, because now interest is an endogenous variable. And then we have 1 covariance. So just to go through this count again, we're going to have 8 direct effects because the indicators and then these 2 paths right here. We're going to have 2 exogenous variables. We have 10 endogenous variables, all of our indicators plus interest, and then we have 1 covariance. So that still adds up to 21. So changing these 2, it changed some of the relationships of the variable. It changed what some of the variables were classified as, but it did not actually change the degrees of freedom. And this is pretty common. If you're just changing covariances for direct effects, the model's exactly the same. All right, so estimate the model. These numbers might look familiar. They are the same. So this is an example of actually equivalent models where our fit indicators are going to be exactly the same for the model that had these as covariances, as well as the model that has these as direct effects. Okay, so this is a particular characteristic of this kind of model where we just changed out covariances for direct effects. In your more complicated models, you do want to make sure that adding those structural components does not worsen the model fit too much. And the process would still be to look at the modification indices and make changes where you can. Keeping in mind that if you're making changes to the measurement side of the model, you might want to go backwards and say, okay, let me refix the measurement side before, let me take out the structural components and fix the measurement side before I look at the structural part. All right, so the output is going to give us everything, but we're going to ignore the measurement part and just focus on the structural part. And this is where it's going to be just like path analysis, where you see it says structural, and this is why it says structural now, if you remember from path analysis. And we have our 2 direct effects. So when we're looking at whether commitment has a significant relationship to interest, we see that it's not significant. And when we look at expiration, it does have a significant effect on interest. Now you might be remembering our correlations that we had where it was like 0.37 and 0.32. And why is it now different? So I want you to think for a second, why is the direct relationship between commitment and interest different from the correlation between commitment and interest? All right, if your answer was because we're now controlling for expiration, then you are correct. When we had covariances here, that was just a bivariate relationship between commitment and interest. It was just whatever relationship was there, not controlling for anything. Once we add in direct effects and we make this a structural part of the model, now the relationship between interest and commitment is controlling for expiration. Same as expiration and interest is controlling for commitment. But as you can see, when you parcel out the variance associated with expiration from the commitment and interest relationship, the commitment and interest relationship is non-significant. So this is why it's an advantage to actually specify direct effects instead of just allowing correlations all the time. So our conclusion here would really be that higher expiration is significantly related to higher interest in school. And so that's it. That's a full structural equation model. All right, so maybe you had this question, but we're looking at ethnic identity when the relationship should be different in different ethnic groups. So yes, in that case, we can add control variables for different ethnic groups. And since we're looking at interest in school, then gender and age might also be relevant because girls tend to be more interested in school and older students tend to be less interested in school. So to specify this, we would add in our control variables. So this would definitely change our counting. And we could go back to the measurement model, but at this point, if we're just adding control variables, then we can stick with making changes to the structural model. But here, what I'm going to do is I'm just going to control for ethnicity, race, ethnicity, age, and gender on all 3 variables. And then we're going to make sure that we can compare different ethnic groups. And remember, since there are 4 ethnic groups, we have 3 dummy variables. And in this case, white is going to be the reference group, just like in regression. Now, we're noting that all of our control variables are predicting the latent variables, not the indicators, because the latent variable takes into account everything about the indicators, or should. Now, when we're adding in control variables like this, we want to be careful about what correlations are going to be left over. Since we have our control variables predicting commitment and interest, they are no longer exogenous. So Stata and R are no longer going to automatically assume that you have a correlation between commitment and expiration. So you would have to specify that directly, because these are now endogenous variables and our exogenous variables are all the control variables. So that's why I have that bold. All right, so we've added 5 more observed variables, so that gives us 105 data points. We now have 15 extra paths to estimate. So that adds a bunch here. We have 6 exogenous variables. And then we have our endogenous variables of our indicators, commitment, expiration, interest. So our model is still over-identified. It's just that those numbers have gone up a lot. And you can see how quickly a model gets complex when you're adding in variables. All right, here's our model fit. It's still wonderful. Actually, our control variables have not changed the model fit very much. And if we look at our parameter estimates, we're still mainly interested in the effects of commitment and expiration. You can see those numbers change, well, for commitment change very slightly, not too much. Some of these control variables do have significant effects, so that's interesting. And if you look at the results on Moodle, you'll be able to see what those are. And then remember, just like in regression, for our dummy variables down here, these are going to be mean differences on each of these variables compared to white students. So even though this is a latent variable, this path here is still estimating the mean difference in expiration for Black students compared to white students. All right, so another question that you might be wondering about is like, okay, well, we have these like controls for ethnicity, but isn't it possible that, you know, just the ways that expiration and commitment are related to interest for students of color compared to white students might just be different? Not necessarily in a way that there's a mean difference, but just the actual different relationships. And in that case, you're describing an interaction, you're describing moderation, and that is possible with latent variables. And that's what we're going to talk about with multi-group analysis in a little bit. So stay tuned. But just to sum up, full SEM is combining 2 skills that we've already learned: modeling latent variables and looking at structural relationships. So some things to keep in mind is that poor fit can come from the measurement part of the model or the structural part of the model. So that's why we do 2 steps where we fit the measurement part first, and then we add on the structural part. Don't be afraid to go back to the measurement model to try and fix issues if you're really having problems. And then keep in mind that your modification indices are only going to suggest small changes, 1 path at a time. So if there are really major issues, you might have to just go back and scrap the whole model. And the last thing is that theory is your main guide. So the data is helping you make decisions, but you still want to make sure that what you are doing is defensible by theory. So that is full SEM.